This is section 1.01 of the Unit 1 Notes, Intro to Income. Today I am, as in you are the student, using tools to convert numbers into different forms so that I can represent the percent of a number. I will also have it when I can convert numbers between forms using specific tools and techniques and calculate the percent of a number. Specific techniques we're looking at for today's lesson is 6.4G. Generate equivalent forms of fractions, decimals, and percents using real-world problems, including problems that involve money. Rounding numbers. Let's do a quick review on what you need to do in order to round a number either up or down. So, if the number you're rounding up or you're rounding is followed by a 5, 6, 7, 8, or 9, then we're going to round the number up. For example, let's say we want to round the number 38. And we're going to round it up to the nearest tens place. So the 8 is what we look at in order to either round up or down, because what we want to round is the tens place. So it being an 8 means we're going to round the number up to a 40. Now, if the number we are rounding is followed by a 0, 1, 2, 3, or 4, we're going to round the number down. So again, for this example, we're going to round to the nearest tens place. We have the number 33. Tens is this first 3, or the 3 on the left, and then the 3 on the right is the 1 place that we're trying to round. Now, because this number is one of the following, 0, 1, 2, 3, or 4, we're going to round to the nearest 10 down. So we're going to round down to 30. Again, wherever we want to round, we're always looking at the next number of that place. So if I want to round to the hundreds place, I look at the tens. If I want to round to the tens place, I want to round to ones. If I want to round to the ones or to the nearest whole number, I look at the decimal afterwards to the tenths. If I want to round to the nearest cent, to the nearest penny, that usually means the hundredths. So we're going to round to the nearest hundredths by looking at the next number, the thousandths in that decimal. Okay? That's what you do in order to round numbers. And again, I just briefly touched on this, but for rounding money, the smallest amount of money you can receive in the United States is 1 cent, 0.01, which is in the hundredths place. A cent is 1/100th of a dollar. Therefore, money amounts can have no more than 2 decimal places. Very important in terms of talking about money. If we have 3 decimal places, even if it doesn't tell you to round it, if we're talking about money, we're always going to round to 2 decimal places, unless otherwise stated. Okay, just checking to see if I didn't skip a slide. So, continuing on rounding numbers, when we make calculations with money amounts, your results may have more than 2 decimal places. Always round to the nearest cent unless you are told otherwise. So, for example, let me cover some of this up so I could talk about it. Okay. So, for example, to the nearest cent, we have the following dollar amount, $128 and then 0.465 cents. Well, we don't typically have 3 decimal places in our when we talk about money. So we're going to round to the nearest hundredth place. Okay? So that 6 is what we're going to look at. Well, I'm sorry, the 6 is what we're going to base our rounding from, and then the following number, the 5, is what we're going to look at. So that 5 will tell us whether to either round up or down on that number. So remember, your numbers for rounding up are if it ends in 5, 6, 7, 8, or 9. It ends at a 5, so this will round up to $128.47. Again, if we round to the nearest cent. Now, let's say we want to round to the nearest dollar amount, meaning no decimals, no pennies, no quarters, no cents in our final answer. So to round to the nearest dollar, we're going to be looking at the 2. and then the number next to it is what will determine whether we round up or down. Now that 6 tells us we're going to round the 2 up. So this is $543 if we round to the nearest dollar. All right, so that's a brief review on how to round numbers. Now onto something just a little bit different. Let's talk about how to find certain prices per unit, okay? Per unit of measurement. So let's say in this example, we have oranges that cost $1.25 per pound. Anna buys 2.3 pounds of oranges. Let me cover this and pretend y'all didn't see that, by the way, and then reveal it as we go. So Anna buys 2.3 pounds of oranges. How much money does Anna spend on oranges? So what do we do with this problem? First, let's figure out what we have. Oranges cost $1.25 per pound. So oranges, which I'll just say as, I'll just spell it out, is $1.25 per pound. Per 1 pound. Okay? Anna buys 2.3 pounds of oranges. So we have 2.3 pounds. Well, how do I figure out what the cost of this is? Well, I have 2.3 pounds, and I know that 1 pound is $1.25. So what can I do with these two numbers? I can multiply them to get my answer. So $1.25. Trying to bring up my calculator. Here we go. $1.25 times 2.3 will be $2.875. Okay, so just to show you what's on the screen right here, we have 1.25 times 0.23 equals 2.875. Now look at the problem. Did it tell us what to round to? No, it didn't. It just says how much money. Therefore, we can assume that we're going to round the 7 either up or down depending on the number next to it. Okay? So, is this going to go up or is this going to go down based on the 5? Well, this will round up. So this will round up to $2.88. And therefore, Anna spends about $2.88 on oranges per pound. Well, in total, not per pound, sorry. That's it for example 1. Okay, on the class kick for the U try, I have a very similar problem. Work through it like we did with example 1. Apples cost $1.15 per pound. Nan, I believe, buys 3.7 pounds of apples. How much money does Nan spend on apples? So the total cost is the cost per unit times the number of units. In our previous problem, the cost per unit was $1.25 per pound. The amount of units that we had in the previous problem was 2.3 pounds. So in class kick, figure out what needs to go in for the formula, what you need to multiply, get your answer, and then round your answer appropriately. So if you would like, go ahead and pause the video, try this problem on your own. Otherwise, I'm going to continue on and show y'all how to do this. Preferably try this problem on your own and practice before you see my answer. If you're on class kick, you can always move this box to check your answers, by the way, and see if you did all the steps correctly. But anyways, here we go. So, apples cost $1.15 per pound. Nan buys 3.7 pounds of apples. How much money does Nan spend on apples? Well, the total cost is the cost per unit times the number of units. The cost per unit is $1.15 per pound. The number of units is 3.7 pounds. So, In order to figure out how much total money she spent, we need to multiply the two numbers. So 1.15 times 3.7 is 4.255. Rounded to two decimal places, the 5 should round up to a 6. So our final answer is $4.26. I'm just going to move the box to check to see if we did everything correctly, and it looks like we did. That's it for you. Try number 1. Okay, now the previous problem that we looked at was a multiplication problem. So per pound, how much money does Anna spend on oranges? How much total money does she spend? Those are all clues that indicate a certain operation. In this case, this indicated we needed to multiply. Now let's look at example 2. Now we know the total cost of the house is $175,000. The house has 1,850 square feet of living space. To the nearest dollar, how much does the house cost per square foot? So we know totals, okay? We know total house cost, and we know the total square footage. Now we want to break it down even further to how much does it cost per square footage. So cost per square footage. The cost per usually means a division problem. So 175, well, let me say this. So that means we're going to divide whatever the cost is by the square footage. Okay, let me black this out, and then let's talk about this. So we're going to divide 175,000 by 1850. So again, divide these two numbers to get how much it'll cost per square footage. We know our totals, and we know we now want to break it down to what is the cost per square footage. Whereas here, we know what it is per pound. We know how many pounds we have. We wanted to find the total amount. Example 2, we have our totals that we want to break down even further into their parts. So that's why this is a division problem. So divide these two numbers. 175,000 divided by 1850. And we have 94.59459, etc. And it looks like it repeats the decimal. However, it wants us to round to the nearest dollar. The nearest dollar is this first 4 to the left of the decimal place. So the number next to it is going to help determine whether we round up or down. Because that number is a 5 or greater, that 4 will round up to 95. So, again, this is what we have right here. It'll round up to $95. The house costs about $95 per square foot. That's it for example 2. You try number 2. A house costs $185,000. The house has 1,750 square feet of living space. To the nearest dollar, how much does the house cost per square footage? Again, this scenario indicates we are dividing. We have our totals. We want to divide it into their parts. So the cost per square footage is the cost of the house divided by the square footage. So figure out what it is you need to divide, what goes first and what you need to divide into it. Round your answer to the nearest dollar, and then type your answer up in ClassKick. Again, if you're on ClassKick, you can move these boxes and check your answers if you would like to do so. So go ahead and pause the video. Try this problem on your own, either on ClassKick or on paper. Otherwise, I'm going to continue on and show y'all how to do this. So, the cost of the house, $185,000. The house has 1,750 square feet. This is the cost per square foot. So this tells me I'm going to take the money, the dollar value, and divide it by the square footage. Cost per square foot. So 185,000 divided by 1,750. We're going to round it to the nearest dollar. So we're going to stop at this 5 right here and then look at the next number. If it's 5 or greater, that means this 5 will round up to a 6. If it's less than 5, then it will stay a 5. Excuse me. So the number next to it is 5 or greater, which means that 105 will round up to $106 per square foot. And then there's our answer. That's it for you. Try number 2. All right, some more reminders about fractions, decimals, and percentages. It's going to be good to have this skill down. The skill of going from a fraction to a decimal to a percentage, and and going backwards. Okay, being able to change between all 3 different forms. Okay, so each one is like a different language. We have the language of decimals, we have the language of fractions, we have the language of percentages. They all mean the same thing. Decimals, fractions, and percentages all mean the same thing. They're just represented differently. Decimal of 0.5 is the same as a fraction of 1/2, is the same as percentage as 50%. So what a percent is, as a reminder, the ratio of a number to 100 shown by the symbol percent, the percent symbol. So percent literally means per 100, which can be further translated to for every 100, for every 100 parts. Decimals to percentages. To convert from a decimal to a percent, we're going to multiply the decimal by 100 and attach the percent symbol. There's also a shortcut that we can do, which we'll talk about in a little bit. Okay, so take whatever the decimal is, which is 0.5. If we want to change from decimal to percent, we type in the decimal. In this case, the decimal for 1/2 is 0.5. Type that in, multiply by 100 to convert it to a percent. And we have 50%. And that's it. Now, if we're changing from decimal to percent, the shortcut is to, I think I have it in the next slide. Yeah, I do. So I don't need to write it. So to convert from a decimal to percent using the shortcut, you can move the decimal point 2 places to the right and then just attach the percent symbol. So again, take the decimal point, move it to the right, 1, 2, fill in any gaps with zeros, and put the percent symbol at the end, and you're done. So that's going from decimals to percentages. Now, to go from percentages to decimals, we go backwards. So we can, let me make sure I have it. Yep. So going off of the shortcut, we start in percentage form, and we take its current decimal place, which is where the percent symbol is at, and move it to the left twice. Then if there are any missing values, just put those zeros in, and then we will have 0.75 as our decimal form using the shortcut. If you don't want to remember the shortcut, if you want to remember how to use the calculator instead, remember, going from decimal to percentages, we multiply by 100. Going from percentages to decimals, going backwards, we divide by 100. So to convert from a percentage to a decimal using the calculator, divide the percentage by 100 and then take away the percentage symbol. So we have 50% in this case. Divide that by 100 and we get 0.5, the decimal form. So again, take 50% or whatever percent, divide by 100. You will change it back to its decimal form. Okay, so here's some practice to go from percentages to decimals. Convert each percentage to a decimal. And remember, the way we converted percentages to decimals was to divide by 100. If you forget, go back to the notes, look at the part that you need to, and then apply that section of notes to the U-try. Convert every percentage to its decimal form, either using the shortcut, moving the decimal point to the left twice, or by dividing the percentage by 100. So if you would like, go ahead and pause the video, try this problem out on your own. Otherwise, I'm going to continue on and show y'all all the answers. So we already done 50%. That's 0.5. 12.5, we can use either the shortcut or divide. So I'm going to use the shortcut. Move the decimal point to the left twice. If there are any blanks, fill those in with zeros. I don't see any. So our final answer for the decimal is 0.125. You could also just divide by 100. So take 12.5 divided by 100. And you will get your decimal form right there, 0.125. Same thing with with 3%. Take the decimal point where the percentage symbol is at, and then move it to the left twice. Any gaps you fill in with zeros, and we have our decimal form. If you would rather use the calculator, type in type in 3, divide that by 100, and you will get 0.03 as your decimal. Last two answers, 0.75 using the following method, the previous methods, and 0.25. That's it for you. Try number 3. Percentages calculations. Now, when we do math with percentages, we have to convert it to its decimal form. So if you see a percentage and you want to use that percentage in some sort of math problem, you have to always change your percentage to a decimal. Okay? So you have to translate it to its decimal form before you do any math. More things about how to apply these symbols. So the word of, we're fixing to do word problems, so this is why we're talking about this. The word of typically means to multiply. The word is where the equal sign goes. So let's look at some examples here. So for example, what is 70% of 90? So 70% of 90. What is 70% of 90? Is means equals. What is this equal to? What is all of this equal to? We don't know. So this is the part we're trying to find out. But and what are we trying to find out? 70% of 90. Now 70% in its decimal form, divided by 100 or move the decimal place to the left twice, should be 0.7 or 0.70. Of means we're going to multiply these two together. So 0.7 of 90. 70% of 90. So 0.7 times 90 is 63. And there we go. I believe this little part is just telling you how to set this up, and then the next slide is showing y'all how to do this. I'm kind of doing it in this one slide here, but I'll talk about it in a little bit. 70% of 90.7 times 90 is 63. So 63 is 70% of 90. Now, if you want to check your answer, let's divide these two numbers. So I want you to do 63 divided by 90, and it should give us 0.7 if we did this correctly. And it does. So 63 out of 90 is 70%. Okay, here's another example. 28 is, so look at those keywords, is 40% of what number? So what is this equal to? This is equal to 28. 28 is 40% of what number? So 40% we know is going to be 0.4 if we convert it. Of what number though? So multiply by what? We don't know. We don't know what that value is. So in this case, this is our unknown x value. 0.4 times x. Okay? Now, what do we do? How do we find out what this number is? Well, this is a math equation. 0.4 times x equals 28. We need to solve for x by doing the opposite of whatever is attached to that x. Right now it's being multiplied with the 0.4. So what do we do to get rid of it and move it to the other side? We divide both sides. So we're going to divide by 0.4 on both sides. Excuse me, on both sides. Okay, that's going to cancel out here. And we have 28 divided by 0.4. Okay, 70. 70 is our answer from this. So we will divide to solve the problem based on the way that we set this up. And again, this is all equal to, or x is equal to 70. Now, if you want to make sure everything is correct, let's try and divide these two numbers, and it should give us the decimal back, 0.4. So let's divide the part by the whole. 28 is the part, 70 is the whole, and we get 0.4. So we did this correctly. Okay, and again, this next slide right here kind of shows you the math of what I was trying to show y'all. We need to divide 0.4 into both sides. These will cancel out. 28 divided by 0.4 will give us 70. All right, now the last one. Again, this is our another scenario. What percent of 40 is 12? So what do we have? Is our equal sign. So we know this is equal to 12. We know that for our to get 12, we have to multiply the percent with 40. But we don't know what our percent is. So x is 40. Well, x is our unknown in this problem. What is the percentage? So just like the previous problem, x is on one side of the equal sign. We need to get it by itself by moving whatever's attached to it to the other side by doing its opposite. So what's the opposite of multiplication? Division. We're going to divide both sides by 40. Divide both sides by 40. So 12 divided by 40 is 0.3. Now, this is our decimal form. It asks for percent. So there's an extra step that we got to do. To go from decimal to percent, we either have to move the decimal point to the right twice or multiply by 100. Either use the shortcut or multiply by 100. Either way, you should get 30% as your final answer. So again, here's our setup. And here's how we do it. 12 divided by 40, and then whatever our result is, times 100. 30% is our final answer for that. Okay, so this is just showing you all the different scenarios of these types of problems. So you need to know what is represents and what of represents in terms of setting up an equation. Is our equal sign. Of is our multiplication sign. And then you need to know what is missing, what's being multiplied, etc., and what will you do to find that missing value. Okay, because notice we have three different setups. We have one setup where you just have to multiply the decimal form of the percent with the number, and then you get your answer. And we have two different scenarios where we had to divide one of those numbers to the other side to get what is missing. Okay, so that is it for this lesson 1.01. If you have any questions, let me know. Otherwise, I will see y'all later.